Bismillahirrahmanirrahim. Today we'll deal with the dynamic memory allocation. What else? Dynamic memory allocation. So, why we need at all the dynamic memory allocation, and what is dynamic memory allocation? The thing is that we declare, for example, arrays. We declare integers. If we say here, for example, int AR of size 100, so I have got the 100 bytes, not 100 bytes, 100 to 400 bytes reserved for AR, right? But the thing is that maybe tomorrow we need only 10 bytes and I'm reserving 100, so it will waste memory. Or second case, maybe we need 200 integers and we have only 100, so we can do, it's still a waste. We have to declare another array of size 200, it will not do, right? So we have both problems. Either we need more memory, so it's a problem, or we have already, what we have the memory but we are using very little and we waste the memory. So it's not a better idea to give memory at the compile time, so better we give memory at runtime. Whatever memory we require, we create that at runtime. So what I'm talking about is here, when you say int AR of 100, you're basically reserving 400 bytes. Reserving memory is given, but I say I will not get a memory. I don't want a memory right now. Let me create memory at the runtime. At the runtime, when the program is executing, you ask the user how many integers he wants. He says 10, 20, 5, 2, whatever he says. We will create memory of that much, right? So, but C doesn't have a inbuilt memory for declaration for that, but we have a one method or a function, we say, called malloc. There are many more, calloc and realloc. We have one of the things is called malloc. What? Memory allocation. M-A-L-L-O-C, malloc. And first thing what we want to do is we have to create, because this the malloc function has its prototypes, its declaration in the library, standard library stdlib.h. So we have to include stdlib.h because it is malloc. The prototype of malloc is in stdlib.h, right? So we have to include, first thing is to include stdlib.h. Now I want to create memory. So if I want to create memory, then what else I should have? I should have only a pointer. I should only have what? Pointer. I declare only a pointer, and at the runtime I create memory and I point this pointer to that memory. When you create an array or whatever you create, right? Whatever you create an array or you create whatever, that will be okay, that will be on a heap. We have an array in a heap and the name AR itself is in a stack, AR, and this AR is pointing to the heap. If you declare int AR of size, for example, 100 or whatever, this 100 into 400 bytes will be reserved here, and this AR is itself in a stack and this points to these 400 bytes. So if I want to create this at a runtime, right, but I still need a pointer which will point to that memory. So in the runtime I will ask user how many memory you want to create. He will say this much of memory, but I need a pointer which can point to this memory, right? So I declare only a pointer at the compile time. So I will have a pointer, right? Why pointer? Because pointer is something which takes the address. Now this time we take the address of whatever memory we create, and who will create it is the malloc chachu. You will call the malloc chachu and tell him, hey malloc, we want this much of memory. He will reserve that in a memory, okay, in the heap. This is called heap, is a free memory, okay, and you have already a pointer, and we have to link the address of that memory with the, isn't it common sense, right? We had arrays, we have whatever we have, right? They have a name right? Like ARI put in here and then a memory. Both the things are done on the compile time. Memory is reserved, okay, pointer name, and that is linked. It is on a compile time. Now we are disjuncting this. We say do this, but don't do this at compile time. Do it on runtime. You create memory at the runtime and then link it with the pointer. Now one thing is that we may have the integer requirements, we may have character requirements, we may have floating point requirements, right? But we have only one malloc. Now how is it possible to create memory of type integer, of type float, of type whatever, right, with a single one? What we have done a trick is malloc creates a memory, but it doesn't return the integer pointer. It doesn't return because it has returned the address of the created memory. Whatever the memory it creates, it is address for 255. Malloc has to return that address because this address is to be stored in the PTR, so that PTR tomorrow can access this address. Where we can say asterisk PTR value at this address. Isn't it? You getting me or not?
Yes, sir.
Sure, Farana. So what I'm saying is, but we need. I told you if we have an integer a to point to this variable, I need integer asterisk PTR, a pointer which is of type int. If it was a character, I need a character pointer. If this is a float, I need a floating point pointer. So similarly, if I need integer memory, right, the pointer should be integer. We will have a pointer, integer pointer, right? We have character pointer for characters. We have floating point pointer for floating points. But the problem is single malloc. What the trick we have done is we do not return any type of address. We make this malloc as a general purpose. Then what we do is, but we want that this, if this I want, for example, I have the integer pointer, this memory should be integer, right? But the malloc doesn't do it. It is we who does the typecasting, because we have the typecasting. You know, I've taught you typecasting, right? Which temporarily makes something as some data type, isn't it? Have I taught typecasting? For example, we have int a, we have float b, right? I say a equals to file. Okay, I'm saying b equals a over 2. So what should go in a b? B is a floating point, it can take points. A is 5, 5 divided by 2 is 2.5, so B should be 2.5, right? If I printf percentage D, I would go close. Is it percentage D or F? It should be F, right? Because B is comma, what else? B. It should be 2.5, but he is saying इसमें 2 जाएगा. That is the issue. Now if we run it, it is 2.0, not 2.5. The answer is 2. Yes.
सर क्योंकि हमें पहले फ्लोर बनाना है टेम्पररी.
कि मैंने पढ़ाया था, ठीक है? ये पढ़ाया था मैंने?
Yes, sir.
So what I'm saying it is A. Then why don't you remember, you guys? Because A is integer. A is what?
Integer.
If you divide integer divided by 2, it does integer division. What it does is it will have a 2.5 answer, but it will cut the 0.5. It will have only 2 answers. B can hold 2.5. B is a floating point. It can hold 2.5, but the problem is A is cutting 0.5 because A itself is what? So it's cutting 0.5. So it cannot be. It cannot put into the. So whatever it is here, it will be here only 2, not 2.5, because A is 5. 5 divided by 2 is 2.5. So A will cut the 0.5 because it can't hold the whatever, right? So it becomes integer division. So the answer out of it is integer division, that is only 2, even though B is floating point. So what you say is, hey, we do what? Hey man, make it temporarily float. A is int, but make him temporarily float. Only for this statement, make him float. Rest of the life of the program, A will be integer, but only for this statement, make him float, right? Now what? When I give it a go, you will say B will be having 2.5. 2.5. You getting me? So this is called typecasting. Even though A was int, I am making temporarily it float. I'm upgrading it to float temporarily, but only for this statement. Rest of the program, it will be int. This is called typecasting. Similarly, I was talking on here that the malloc doesn't return any type. But if I want that the memory should be floating, right? What I do is I will typecast it to the float. If I want it should be character, I will typecast to character. If I say it should be what? Integer. I will say typecast it to integer. But the beauty of this is I can use malloc for everyone. I don't have to use different malloc versions for float, for character. It will become then complex, right? They have made it very easy. You reserve memory, right? Then you want to point to the integer pointer, typecast it with an int. Okay? If you want to for character, typecast it for character, or float, typecast it for float. You getting what I'm saying? So what I am saying is now malloc will reserve memory, but we have to tell malloc that how much memory you want, right? For example, the int asterisk ptr, I got a pointer. Now remember, it's not an a was here, a was a simple integer, so I had to use float only. But if the a is a pointer, I have to say here typecasting time, I have to say float asterisk. If I want to typecast the pointer, I have to use asterisk, right, to say it's a pointer. If it would have been a simple variable, then it's to say only float. You getting me? Now whatever, I got a float int asterisk period because I need a pointer. Why I need a pointer? Because I want to put the address of the memory allocated dynamically, okay, into that pointer. And whatever the pointer it is, I have to typecast malloc then. This time it is of what type? So I have to use typecasting. I will say what? Int or int asterisk? Int asterisk, because this is the pointer. We're dealing with pointers. So we typecast, we say int asterisk. You getting me? It's very simple things. We plug in all the things. So I'm saying I will create only one integer, only one integer right now. We can create a many, okay, and it will act like an array then, because pointers and arrays, they're basically same, because array is nothing but a pointer. So when I said pass it to the function, I said array cannot be passed by value, because there is a pointer. It is only passed by reference. Does it make sense? You getting me? So this time around I will create only one variable. I can create 100, 200. It is up to the user who will tell me what else, right? We'll do that also, but this time I'm saying what? I want to create only one pointer. So how I create the first chunk of 4 bytes, because I have to create how many? 4 bytes, right? So I can say like this. I can say like this. I say ptr equals. Now I have to use malloc. And malloc is a function which creates memory for us, but we have to tell malloc how much of memory. If I plug in 4 bytes, simply, you can plug in 4 bytes, and you have to say here, what else? Typecast it to the int asterisk, because malloc returns, remember, malloc, I repeat, malloc returns void pointer. Malloc, write down. Malloc returns void pointer. It returns a pointer, means address of the memory which it has allocated, but of type void. Of type what? It has no type, so we have to typecast it so that it suits our pointer, because our pointer is the integer type. I will say int asterisk. If it would have been character type, then you will say char asterisk, right? Because malloc returns void, it doesn't return any type, so we have to typecast it so that it suits our pointer. You getting me? Does it make sense to have int asterisk here? Sure? Okay. Good. But I'm plugging 4, but this is not a good idea to put in 4, because I know in this C free I'm using, right? Integer takes 4 bytes. But if you run the same program in your DOS based, there will be 2 integers, so you have a problem, right? Here it will not have any problem, right? Because the 4 means the 4 bytes means it declares 4 bytes. It creates what? So better we say, because I want to create for int, right? What do I say size of int? What do I say what? This is not the same thing for here right now, because size of int means 4, right? If I create for new here code template C, I'm saying printf \n %d \n double close comma. What else I want to print of is size of int. So what should it print? It will print the whatever the size of int is, and that is how much? 4. Definitely it will give us a 4. 4, right? Because size of will give the what are the size of int is. Now this size of int will work whether it's a DOS, whether it's whatever. Because in the DOS it will plug in here 2. If it is 32-bit operating system, it will plug in here what? 4. So it will run, your program will run in both the platforms, whatever you want to put in, right? So hard coding 4 is not a good idea. Okay, say size of int, right? Size of is a method. We call the method, basically I'm using more Java, it's a function, right? We call actually methods, functions, methods in Java and C++, whatever is a function, what we call here functions, right? Size of is a function which gives size of whatever here is data type. You say char, or tomorrow you can say your structure student, and you plug in here student, it will give the whatever size of student is. Now char, it's one byte, right? If you say float, even if you want to know what kind of platform you are, you want to know what the sizes are, you can use the same thing. Okay, float 4, right? We may other guys like double, yeah, and so on, long int, short int, and all that you can plug in. Now whatever, what I'm doing what? I am creating a 4 bytes in a memory, and I'm putting the address, because malloc returns the address of those 4 bytes. Malloc is a function. In the parent side, I tell you how much of bytes you wanna. I say size of int means 4 bytes. I want how many? So it creates 4 bytes at the runtime. When it is running, it creates 4 bytes for us and returns the address of that. And I cast that address to the int that suits my PDR, right? And what it returns basically is the address. What it returns? Because in a memory, for example, you have a memory. Okay, here we go. We have a huge memory, for example 4 gigs of memory in your laptop, and somewhere down in the memory it creates your memory 4 bytes. It creates what? And that will have an address in this memory. Say for example 0x4404 is the address. 0x means hex, 0x means what? Hexadecimal. We usually have the addresses in hexadecimal. Whatever, don't want to confuse with that. I mean, say it has some address. Say for example 2555. It is 255 in the memory. Memory starts from 012 up to 255. I have given this 4 bytes. Now what malloc returns is this address where it has put those 4 bytes in the memory. The address of that. That's what? 255. So PDR will hold 255. You getting me? One more thing for it. One more thing is that maybe you are running out of the space. You don't have any memory, or you are trying to allocate a very huge memory. Okay, and the memory is not there. So malloc fails. So malloc, if it fails to allocate memory, what it returns is not a pointer because it has not created memory. What should it return? Can you tell me out of your intuition? What should it return if the memory doesn't? It fails to allocate memory. If it allocates memory, it will return what? It will return the pointer. It will return the address, sorry, of that memory. If it doesn't, if it fails, null. Yeah, null. It will return the null. It will return what? Void means nothing. Null means something, right? So it returns null. It returns what? Null. So we had also, before we do something on that PDR, we should also check if that PDR holds something or not. If it holds null, that means what? That means malloc has failed. So we had to give info that, oh dear, malloc has failed. If the PDR holds null, what does that mean? Malloc has failed. No memory is being allocated. So if PDR has something, what will it have? What will it have? Address of the memory created by malloc, right? Good. Now I can do what? I can put things into the, now I can use a simple pointer functionalities to put the values into the PDR, okay, and to get things out of it. Simple pointer, right? If I want to say printf enter value into pointer memory, enter. Should I say first? Should I not first? Use if condition. If ptr equals to null, what does that mean?
No.
Printf oops malloc failed. Okay, you don't have a memory. What else? What's happening else?
Set code double.
Oh, there should be the code solvers before you go to play basketball, right? Else we can have a bunch of things here. I'm saying enter the value into the memory. Just created by Malloc Chaju. Okay, so plug in the value. Now who will say I will use a scanf, isn't it? I will scanf because it's an integer value. Okay, not necessarily this percentage d double quote close comma. Should I drop it? Where I should drop it?
PTR.
What should I say here?
Asterisk PTR.
Should I say ampersand ptr?
Asterisk PTR.
Should I say asterisk ptr or ptr? Ptr, because ptr is the address. Ptr is what? Asterisk ptr will give you what is inside. Okay, if I say ampersand ptr, that means address of ptr. If I say normal variable a, I say ampersand a, address of a. What is ptr holding? It doesn't even hold the address of that memory, is it? Don't remember this? Look at it. I say int a equals to 23, right? Why you forget things? And I got the int asterisk ptr. Maybe I have here a asterisk ptr also. I say here asterisk ptr and a. Now what I'm doing is I'm putting in a ptr. I'm putting in a ptr is equal to ampersand a. So ampersand a and ptr is one and the same thing, isn't it? Because I'm putting ptr into ampersand a, so ampersand a or ptr is one and the same thing, right? Now if you want to put, for example, I will print if I print ptr, what will it give?
Certificate address of A.
If I print ampersand a, what will it give?
Certificate value.
So if you are scanf, you are doing scanf percentage d ampersand a, cannot you use ptr instead of that? You are doing scanf percentage d ampersand a, but ampersand a means same as ptr, so I should say scanf percentage d ptr if I use pointer, right? If I use a, I should say what? Ampersand a, is it? So what should I use here? ptr,
PTR.
isn't it? Okay, now if you want to printf, then printf backslash n, mashallah, the value in ptr is percentage d double close comma. Now who tell me? Yeah, asterisk ptr, value at address. Ptr is holding the address. What is the value in that? Asterisk ptr gives me exactly the value. Is it or not? So I run it, and there is some problem because there is no brace. In fact, with the main there is something happening. Why is the main doesn't have a brace?
Else code else.
Oops, what has happened? Where does the main goes? Now there are two, I guess. Problem was of this, but main has something, I guess, on the downside, is it? It has no. Then what's the problem? एक ही था, दो थे. Enter value, फिर वो है कहाँ पे वो brace? Whatever. Enter the value into the memory just created with the malloc chachu. So you say 24, and you got ptr is 24, right? You created successfully the memory. Now then, write it, because I'm not going to give this video to you guys, right? You write it. Be interested. I'll pause and write this resume. Okay, so what I'm saying now is this was a one integer. Maybe we have 10, 20. Okay, maybe better we ask user. We have here an integer value, for example, say limit. Okay, we'll ask user printf enter how many integers. Okay, the user will give us, say, for example, 5 integers, 4 integers, 2 integers, whatever. So we scanf
Length. Percentage.
into percentage d double close comma ampersand
And then
limit. Now I have in a limit the limit how many integers you want, right? So when you create a pointer, you don't need to create anything other than a pointer. Like array, you can have a 10 array, 20 array, 100 of array. AR is a single pointer which points to the base address. Then you can have other things with that indexing, right? जब array हम करते हैं हमारे पास 100 बाइट्स होती हैं, 200 बाइट्स होती है, लेकिन नाम कितना है, पॉइंटर कितना है, एक ही. इसी तरह पीटीआर एक ही खड़ा होगा और मेलॉक, लेकिन साइज ऑफ, अब मुझे साइज ऑफ इंट तो एक का देगा, मुझे कितने चाहिए, लिमिट इनटू, फॉर एग्जाम्पल इसने कहा 2 इंटीजर्स, सो 2 इंटू साइज ऑफ इंट कितना है 4, 2 इंटू 4 इज, सो आई विल 8 बाइट्स और पीटीआर विल होल्ड द फर्स्ट एड्रेस. इसलिए इंट एस्ट्रिक बोलना जरूरी है. अगर एक ही होता फिर बोलना जरूरी नहीं था, लेकिन बहुत सारे इंट एस्ट्रिक बोलना जरूरी है, क्योंकि जब मैं पीटीआर को आगे चलाऊंगा, पीटीआर प्लस प्लस करूंगा, वो 4 बाइट्स प्लस प्लस होगा खुद ही. कितना, 4 बाइट्स, क्योंकि एक इंट 4 लेता है. जब मैं पीटीआर प्लस प्लस, इट विल गो टू अप टू द आफ्टर 4 बाइट्स, बाइट नंबर 5th, दैट इज द स्टार्ट ऑफ द सेकेंड बाइट. यू गेटिंग मी? सो इसलिए इसको इंट एस्ट्रिक बोलना बहुत जरूरी है. कैरेक्टर होगा, कैरेक्टर यहाँ पे होगा तो उसको एक ही बाइट आगे चलना है. So if I say ptr plus plus at that time, it will increment 1 1, and here it will increment how much, 4 4, whatever. अगर आपके DOS है तो 2 2, because जो जितना ये int का size होगा. Yes. So period is called into asterisk, malloc limit, whatever the limit we have, into the size of int. Size of int will give how many bytes I have into the limit. Limit means 4 चाहिए, 3 चाहिए, 2 चाहिए, वो user बोलेगा. So we will have basically an array, contiguous array of memory, and it is the PDR which holds the address of the first, right? For example, he may say 4, limit is equal to 4, so 4 into 4 is 16. So 4 integer variables for in space for 4 integers we will have, right? And PTR is holding the address of what, first. If I go to second, I say PTR plus plus, but if I do PTR plus plus and PTR plus plus would go forward, मेरा base address घूम जाएगा. इसलिए जब हम array करते हैं, क्या करते हैं, array is a static pointer. You cannot change the address. You cannot change this array address because वो base, वो मैं बता चुका हूँ जब मैंने array पढ़ाया था. Because AR is of size, for example 4, will reserve 4 bytes. Basically 4 bytes there, na? 4 bytes. You getting me? Not bits. 4 bytes. 8 bit each. 1, 2, 3, and 4. 4 bytes for 4 integer these things. Is it 4 bytes? No, more. 16 bytes. It should be 16 bytes because 4 bytes for one, 4 bytes for another integer, 4 by another, 4 by another, 16. Total 16. Yes, 16 bytes, right? Total 16 bytes क्योंकि एक इंटीजर 4 लेता है ना, 4 bytes लेता है. ओके, ए और जो है अब यहाँ पे है, ये बेस एड्रेस पकड़ेगा, इसका एड्रेस बेस का, ठीक है. इसका एड्रेस मतलब 220 है, तो इसका कितना होगा,
224.
यस, इसका एंड सो ऑन. So AR will hold this. If I go here, I cannot say AR plus plus. AR is a static pointer. You cannot change it. You cannot change it. It's a static pointer. Remember, array is a static pointer. You cannot change it. Okay. If you want to go to next, you have to say AR of 1. Yes. AR of 1. It does what? Whatever the AR value has plus 4. 1 means 1 byte. 1 integer means 4 bytes. AR has a 220 plus 4 is 224, but it will not put the into AR because saying PTR plus plus means whatever is in PTR, do PTR plus 1 to that. If PTR में 2 है, 2 plus 1 is 3. It will be updated. वैसे AR plus 4 you are not assigning to AR, you are not assigning to AR, right? You are not assigning to AR, so AR अपना ही रहेगा, लेकिन AR plus 4 निकालेगा. इशफाक के पास 2 है, अगर मैं कहूँगा इशफाक प्लस प्लस ये 3 बनेगा. मैं कहूँगा इशफाक प्लस 3, इशफाक के पास ना 2, 2 + 3 is 5. मैं 5 पे जाऊँगा, लेकिन इसका अपना ही रहेगा 2, इसको मैं चेंज नहीं कर रहा हूँ, ये फ़र्क है. सो AR को आप चेंज नहीं कर सकते, लेकिन PTR को चेंज कर सकते हो. PTR इज नॉट अ स्टैटिक पॉइंटर, राइट? जो मेरा PDR है ये स्टैटिक पॉइंटर नहीं है, यू कैन चेंज इट, लेकिन अगर आप चेंज किया तो बेस एड्रेस घूम जाएगा, इसलिए इसका ख्याल रखना है हमें. ठीक है, यू आर नॉट गेटिंग, वी आर लुकिंग ऑन दैट साइड देन. ओके, नाउ इफ PDR is having null, that means I have no memory. If it is not having null, now I have to initialize all the 4 or 5 or 10 or whatever the limit he will say. So I will use a loop for I equals to 0, I
अगर इसके पास पूरी मेमोरी नहीं थी हाफ ही, लेकिन यहाँ पे 4 बाइट्स मतलब 4 इंटीजर्स या 2 इंटीजर्स,
it will return null then. It will return what? आधा नहीं देगा. ठीक है, I can say for I is equal to 0, I less than equal to limit, less than limit, 0 शुरू कराओ ना, I plus plus. ओके, पहले मैं यहाँ पे क्या काम करूँगा, मैं यहाँ पे एक और वेरिएबल करूँगा I खड़ा, लूप वेरिएबल, और एस्ट्रिक PD, एक PD वेरिएबल. ठीक है, क्योंकि पॉइंटर वेरिएबल मैं सेव करना चाहता हूँ, वो सेव रखना चाहता हूँ. मैं यहाँ पे क्या करूँगा, पहले काम मैं PD में डालूंगा PDR. ठीक है, एंड PD एंड PDR बोथ पॉइंटिंग टू द फर्स्ट मेमोरी लोकेशन, राइट? अब PD के साथ चेंज करो, लेकिन PDR को अपनी जगह रखो. PDR विल होल्ड द बेस एड्रेस, PD को आगे बढ़ाओ. फॉर I इज इक्वल 0, I लेस देन लिमिट I प्लस प्लस एंड कामा PD प्लस प्लस. PD को प्लस प्लस करो आगे, you will scanf, I will say printf enter the value, and I will scanf that into what, percentage %d will close comma in what, PD, right? Direct PD because the pointer, right? ये अभी पढ़ चुके हम, ये PD में सीधे डालेंगे. ठीक है, और आगे बढ़ता जाएगा ये 3 4 कितने जितने लिमिट होंगे उतने, तो ये बढ़ता जाएगा. इसी तरीके से अगर मुझे, मैं इसको कॉपी करूंगा यहाँ पे, अब PD तो आगे गया ना, PD कहाँ गया, वो तो लास्ट में पहुंचा ना, चौथी बाइट पे PD प्लस प्लस ना करा, इसलिए ना PT वापस वो PTR बेस एड्रेस पर PT वो ना ब्रो ना, PD को वापस लाएंगे PTR के ऊपर, और फिर हम कहेंगे फॉर I इज इक्वल 0, I इज लेस देन I प्लस प्लस PD प्लस प्लस. अब एंटर द वैल्यू नहीं, हम कहेंगे the value is equal percentage %d, right? Double close comma, what else, asterisk PD. ठीक है, backslash n. This thing I don't need, right? Okay, this thing all I don't need, right? What I'm doing in the else means what, that we have something, yes, PDR is not equal to now. I put the PD, whatever the PDR, that is the PD, same address in PD, same address PTR, both are pointing to what, base address. Then I is equal to 0, I less than limit I plus plus PD plus plus also, okay, comma. तो PD पहले मेमोरी को एलोकेट होगा, PD उसमें डालेंगे हम कोई चीज़. ठीक है, उसके बाद PD प्लस प्लस होगा, यानी कि PD विल पॉइंट टू द नेक्स्ट इंटीजर बॉक्स, बिकॉज यू हैव गॉट हियर जितने आपके पास लिमिट था, अगर आपने 4 कहा, 4 इंटू साइज ऑफ इंट 4 4 16, यानी कि 4 इंटीजर्स के लिए जगह खड़ी हुई है ना. PD पहले इंटीजर के लिए PD के पास होगा, और जैसे लिमिट कहा 4, इसने लिमिट क्या कहा, तो 4 इंटीजर्स के लिए जगह होगी. 1 2 3 and PTR is pointing to this, right? Now I'm saying PTR, PT is equal to PTR, so PT is also pointing to this. PTR में base address है. When I say PT plus plus will go here, PT plus plus will go here, PT plus plus will go, ये 4 बाइट्स की जंप मारेगा खुद ही, क्योंकि PT जो है वो इंटीजर पॉइंटर है ना, जब PT को प्लस प्लस करेंगे ये 4 का जंप मारेगा, ठीक है? तो यानी कि दूसरे इंटीजर के पास जाएगा तीसरे. So when I drop it into the PT, drop it into the PT, PT plus plus drop it into PT, PT plus plus drop it into PT, PD plus plus drop it into PD, and it will come out of the loop because of the limit. जितने लिमिट होंगे, जितने ये डब्बे होंगे, उतने हमारा लिमिट होगा.
अगर हम PT plus 1 करेंगे तो इस बार पड़ेगा,
वो भी वही होते हैं.
वो भी वहाँ जंप करेंगे
4 bytes. Because PT plus plus basically means PT is equal to PT plus 1. It is same thing, right? और इसी तरह हम प्रिंट भी करेंगे फिर बाद में. लेकिन क्या होगा कि बाद में क्या होगा कि PT यहाँ पहुंचा होगा, प्रिंट कर रहा हूँ मुझे यहाँ से, इसलिए मैं प्रिंट करने से पहले वापस, क्योंकि PTR मेरे पास है ना, मैंने सेव किया ना बेस एड्रेस, मैं कहूँगा PT इज इक्वल टू, ठीक है, वापस PTR आ जाएगा वापस यहाँ पे. अब प्रिंट करो इसको, PT प्लस प्लस प्रिंट करो इसको लूप में 1 2 3 4 बार 0 से 3 तक, है ना. एंड हाउ विल यू प्रिंट asterisk PD, हाउ विल यू प्रिंट, you will print here asterisk PD, and I guess that's it. We'll have this an error. I don't think so. First he's saying how many integers, so I say 5. Now limit is 5, so it create malloc 5 into, that's how much, 20 bytes. So that means 5 integer variables. Enter the value. I will say 1 2 3 4 5. PD plus plus हो रहा है ना, PD पहुंचा है 5 के पास, ठीक है. अब लिमिट खत्म होगा वहां से, तो ये लूप खत्म होगी, PT वापस आ गया PTR के पास, PT वापस आ गया 0 के पास, ठीक है. एंड इट स्टार्ट्स प्रिंटिंग द वैल्यू इज 1 2 3 4 एंड so what happens is we have 5 integer arrays, with an array of 5, but I'm not allocating in the runtime, I'm allocating in runtime. I'm allocating what, maybe you need now 100 bytes, maybe you need 200, you will say limit 200 integers, huh? Exactly. Maybe you will, what the idea is that maybe you need 20 integers, maybe you need only 2 integers. So अगले अगर आपने array डिक्लेयर करनी है, आपको पहले ही साइज उसका रखना है. मान लीजिए आपने इसका साइज 100 रखा, बाद में आपको 2 ही इंटीजर इस्तेमाल होते हैं, तो बाकी ज़ाया. अगर आपको 100 रखे हैं, मान लीजिए आपके पास 101 जरूरत है, तो पहुंच नहीं सकता. इसमें आपको अपनी मर्जी है आप कितना भरोगे. और मेमोरी हमने कब क्रिएट की, कंपाइल टाइम और रन टाइम. So this is called dynamic memory allocation. I think this is a good intro for this. We have other guys also, and we have also to free this, right? Memory to free, and we have a free for that. Free, FREE is a function which free this memory. Let's say free PTR, it will free the memory. Okay, and there are a lot of more issues to discuss, but right now it's on. Okay.